All right, LeetCode 169, we're back. We're doing a problem called majority element. So in this problem, you're going to be given an array of numbers of size n, and you want to find the majority element. So basically, the element that occurs the most. So there are going to be two solutions to this problem I'm going to go over, although there are a variety of solutions. I think I'm going to go through two of them. One's going to be the most common, one that I think most people should come up with, and it's a pretty good and solid solution. And the other one's going to be optimized a little bit more for space complexity, and I feel like it's more of a party trick. So I definitely don't think it's something you should like be able to randomly pull up in an interview, or I don't think it's very fair to be asked that. But let's do the first example. So I have an example here. So we're given 3, 2, 2, 1, 1, 1, 3, 1, right? And it's very easy to see here that 1 is the majority element because it occurs the most, right? We only have 2 2s and we only have 2 3s, but we have 4 1s, right? So visually, as a human, right, we can see that. How do we let our computer know this in an efficient manner? Well, again, like most problems, I just chuck a hash map at it, right? So in this case, we'll have a map that's going to map from an integer to another integer, right? So we're going to basically just map out the counts of this. So we'll have like a 3. So we'll see that like 3 is going to map to 2, 2 is going to map to 2, and then 1's going to map to 4, right? And then we're going to loop through all of this, and we're going to find that the highest occurring frequency belongs to 1, and therefore we should return 1, right? So let's just put this in a code. Let's put this away real quick. So let's jump into it. So we're going to have our unordered map going from an integer to an integer. We'll call it m. We'll have our candidates. So we'll just keep it like this. And then we're going to say for, we'll just loop through this. So we'll say by reference. So for every n in the numbers, we're going to go through. We're basically going to say that m of each number is going to equal to 1 plus the existing count in there. So we're going to do that, right? So we're going to initiate the count. And then after we have our count, we're going to go through every single thing in there. So for auto, not octo, auto, can't spell today. For auto x in m, we're basically going to go through here. And we're going to say, we're going to basically look at every single count. So we're going to basically do this. If x dot second is greater than r, so we should actually do this. Let's actually make this a pair, maybe. Int. So what this is going to do is this is going to store, it's going to be the number and its count, like that. So we're going to store this. We're going to say if x dot second is bigger than candidate dot second. So if that's bigger, right, what we're going to say is that we're going to say that candidate is going to equal to x, because I think they're both pairs, so we can just assign this to be the pair. So we're just going to do that. And then at the end of it all, we should return candidate dot first. So that number inside there. So we'll do that. And I think what I'm going to do here, though, I think we're going to do int candidate is going to equal to make pair. We're going to put in nums 0, 1, like that, and see if that runs. Cool, that works. Cool, that works. Let's submit. Awesome, so it works. So this is an O of n runtime solution, and it's also an O of n space solution. So basically what we're doing is this map is going to scale linearly with the amount of numbers we have. And this pair is only, it's just a variable pretty much, so this doesn't matter that much. So we'll go O of n plus O of n is going to be O of n. So this is what an O of n space and O of n time complexity solution looks like. So what about making this be more space efficient, right? How can we go about that? Well, there's an algorithm called the Boyer-Moore voting algorithm, I think. I don't think I'm pronouncing that correctly. But basically, what it allows us to do is it allows us to do this problem in that same time complexity, but we only have to do it in O of one space, which is pretty impressive. And I feel like it's a party trick, to be honest. And I don't really expect anyone to like know this off the top of their heads. But the idea is this. So we're gonna have, let's have a pointer to what our most current thing's gonna be. So we're gonna be traversing this array of numbers. And we're gonna have two variables. So we're gonna have, let's change this from green. So we're gonna have candidate. So we're gonna denote who the candidate is. And we're gonna have another variable called count. Cool. So basically, we're gonna start at 3. So we're gonna pick 3 as our candidate. So as far as we know, 3 is the candidate that we have. But, right, we need to up the count because we started at 0. So we're gonna have count is gonna start at 1. And then we move on. We go through this array. We encounter a 2. Well, 2 is not 3, right? So what does that mean? The count needs to be decreased because we just went 1 over in the array and we've encountered something not a 3. So it goes down to 0. But now, since it's a 0, what if we want to replace this and make 2 our new candidate now, right? And we're going to increase this. So now 2 happens once. We know that. We go in and we say, oh, look, current candidate, the current thing I'm pointing at is a 2. The current candidate is a 2. So let's increment. Let's make this a 2 so that we've seen it twice. Then we go here. I said, well, hold on. This is not a 2 anymore. It's a 1 now. So let's decrement back. So now we do 1, right? Let's go again. So we go here again. Oh, it's still not a 2. Let's go down to 0. But now it's a 0. So let's just replace this and make it a 1, right? And then this gets to get changed to 1. So now we know we've seen this once. Then we go here, right? We've seen this now twice, right? We go to a 3. We see that 3 is not a 1. So we go decrement this once again. And then we go here. We see that this is a 1, so we get to increment the count to 2. But by now, we've already finished going through this entire array. So, right, we're going to be like, so we're here now, we're done. And we see that the candidate we're left with is 1, right? 1 is the candidate that we saw occurred the most, right? We see here that the count doesn't immediately represent a 4, right? We know that it occurred 4 times, but here it's not a 4. But that's not really what we're counting. We're counting its occurrence against other occurrences. So it's like a balancing game. So let's try to put this in a code and see if it maybe makes more sense. So let's reset this code to default and let's see if we can make this work. So we'll say int count is going to be equal to 0. So int candidate, and then we're going to go for int by reference n in nums, right? And if the count is equal to 0, right? Like we said, remember when we did that thing where the count reaches 0, we're going to make our candidate, our new candidate is going to be equal to n now. So we're going to do that, right? And then we're going to increment the count. So how do we increment the count? Well, we're going to say the count's going to be plus or equal to, and we're going to say if n is equal to the candidate. So if we're seeing, if the number we're going through, so in this example, if like this green pointer is pointing to what our candidate is, we get to increment it by 1, right? So we'll do this notation. We'll say, okay, cool, I get to get incremented by 1. Otherwise, remember what we did when it wasn't pointing. Let's say we're here and then we reach a 3. Remember what we did? We decremented. So how do we decrement? We just passed in a -1, right? So this is basically saying add add to count. If n is a candidate, just add a 1. Otherwise, add or subtract 1, right? And after all this, it's as easy as returning the candidate. So hopefully this runs. Cool, it works. Awesome. Let's submit. Cool, it runs. So runtime, right? Still that same O of n runtime complexity, but we now have an O of 1 space complexity because we're just initiating, we're taking up a little bit of memory to have this variable to count, right? And we're storing the candidate in another variable that takes up a little bit of memory. But regardless of the size of that vector of numbers, it could be size of like 10,000. We're only ever going to be using these two, the variables right here in memory. So that's all there is to it. Again, this is more of like a party trick problem, but it's one of those problems that once you've seen it and you've understood it, it's kind of hard to forget. So that's the only redeeming factor of this type of problem. So hopefully if you're ever asked this, you can just recall it immediately. And yeah, hope it helped.